Hello students, today I am going to discuss the concept of direction cosines of a vector. How to find the direction cosines of the given vector we will discuss here in this video. So, to understand the concept of this direction cosine, let's consider a right-handed rectangular coordinate system. So, in space, suppose this is the right-handed rectangular coordinate system. This is the x-axis, this is the y-axis, and this is the z-axis here. Now consider a point P that is in the space having the coordinates x, y, z. Means this is the point P, suppose it is having the coordinates x, y, z. Now join this P point to O point. Okay. Then this OP vector will be the position vector of the point P with respect to origin O. Okay. If you want to understand in a better way, so let me use these three markers here. Okay. So this is x-axis, this is y-axis, and this is z-axis. And I am also using a pen. This is a vector OP vector. Clear? The tip of this point is this P. Now if this point P is having the coordinates x, y, z, so what does it mean? It means if we draw the perpendicular from this point P to this x-axis like this, you see this is perpendicular. Okay, you have to think three-dimensionally. This will be the perpendicular. Okay, so the distance covered along this x-axis will be small x. Means you see this is the perpendicular, then this distance, you know, this distance from this cap of the pen and the center, the distance. Okay, this is small x. So in this figure you see, if we draw the perpendicular from this P point, then the distance covered along this x-axis is small x. So this is small x, and let it be point A. Now I am dropping the perpendicular, and you will see that it doesn't seem that it is perpendicular, but three-dimensionally you have to think. So this angle is 90 degree. Okay, either it doesn't seem that it is 90 degree, but I have explained here in by making the model that this angle will be 90 degree. Okay, the same way you have to draw the perpendicular from this point P to y-axis. Okay, now this is the distance small y, and let it be point B. The same way we can drop the perpendicular from this point P to z-axis. So this is, suppose, so this will be the distance z, and this will be the point C. Now you see that small x and small y and small z will be the distances covered along the respective axis x, y, and z when the coordinate is x, y, z. Now let's complete the figure of cuboid in the three-dimensional space. How? This join this, draw perpendicular, this. So this way you have a figure of cuboid here. Clearly now you can imagine the point P in the space, that it is here, and its distance from the O point, that is OP. And OP vector, let's suppose OP vector be R vector. Okay, and the length of OP vector may be written as R. Clear? Now here you see that this angle is 90 degree, this angle is also 90 degree, and this angle is also 90 degree. Now the vector R makes angle of alpha, beta and gamma with respect to these axes. Then alpha will be the angle. This POP vector means R vector makes an angle alpha with the x axis, means this angle is alpha. Clear? Now this OP vector, that is R vector, makes an angle beta with the y axis. So this is beta, and this OP vector makes an angle gamma with the z axis. Now you can clearly see here that alpha, beta, gamma are the angles that are formed by the vector R with the coordinate axis. Okay. Now these angles alpha, beta and gamma are called the direction angles. Okay. Here you see this is the x-axis, so I am making it here. Suppose this is x-axis and this OP vector is this. Okay, and now we draw the perpendicular from this P point, then it meets at the point A. Now you can see this triangle OAP. In triangle OAP, okay, so this angle OA, the distance OA is x and this angle is alpha. Clear? Now the length of OP, that is R. So can we get the value of cos alpha here? Yes, we can get the value of cos alpha as base upon hypotenuse. Base is x and hypotenuse is R. So cos alpha is equal to x upon R. Clear? The same way we can get the value of cos beta here in this triangle OPB. In triangle OPB, cos beta equal to, for this base is y and the hypotenuse is R. So cos beta equal to y upon R. And same way we can get value of cos gamma, that is z upon R. So these cos alpha, cos beta and cos gamma are called the direction cosines of the vector R vector. Means if alpha, beta, gamma are the angles that are formed by the vector R with respect to the coordinate axis, then their cosines, then the cosines of the angles will be called the direction cosines of the vector R vector. So here cos alpha, cos beta and cos gamma are the direction cosines of the given vector R. These direction cosines are also termed as L, M and N. Means cos alpha equal to L, cos beta equal to M and cos gamma equal to N. Now try to get the value of x from this relation. So you will have x equal to LR, y equal to, from this relation you can get the value of y, that is y equal to MR and z equal to NR from this relation. Since P is the point that is having the coordinate x, y, z, so we can also say that the coordinates of the point P may be termed as LR, MR and NR. This is the another way of writing the coordinates of the point P. LR, MR and NR, where L, M, N are the direction cosines of the vector R and R is the length of this vector OP. Now LR, MR, NR that are proportional to the direction cosines of the given vector are termed as the direction ratios or direction numbers of the given vector. Means LR, MR, NR are called the direction ratios. Okay, so direction ratios or direction number of vector R will be termed as A, B, C. These are the direction ratios. A, B, C are called the direction ratios or direction numbers of the given vector. So we should keep it in mind the following things. Okay. So now we should also tell you a relation, that we have a relation between the L, M, and among the L, M, and N, that is the sum of the squares. L square plus M square plus N square is always 1, and it can be proved easily. Okay, how to prove? L equal to X upon R, okay, M equal to Y upon R, and N equal to Z upon R. Okay, now L square plus M square plus N square means X square upon R square, Y square upon R square plus Z square upon R square. So here if we take LCM R square, so X square plus Y square plus Z square. Now R is the length of this OP vector. So let's try to get this length using the Pythagoras formula. So this is, suppose this is joined, then you see that this is a right triangle. Okay, now in this triangle OA, and suppose this is the point D, let's name it E and it is F. Now in this triangle you see this angle is 90 degree, so OD must be equal to OD square equal to this OA square plus AD square, and OA square is X square and AD square is Y, the opposite sides of the parallelogram. So we will have OD square equal to X square plus Y square. Now in this triangle ODP, okay, now in this triangle ODP you see that OP square equal to OD square plus DP square. So OD square is X square plus Y square, and DP square, that is just parallel to this and equal to this Z. Okay, so it is Z square. So OP square means R square. So we will have a relation R square equal to X square plus Y square plus Z square. So R square upon R square, that is equal to 1. So L square plus M square plus N square equal to 1. We should keep it in mind, and we should also keep it in mind that the direction ratios A, B, C, then the relation A square plus B square plus C square needs not to be 1. The sum of the squares of the direction cosines is 1. Okay, but the sum of the squares of the direction ratio need not be 1. Okay, so it was all about the direction cosines of the vector, and in the next video we will discuss the different types of vectors. Okay, so keep on watching my videos. Bye. So keep on watching my videos. So we will meet in the next video. Till then, keep on studying.